Hello, this presentation is a guide to running a family of large language models called LLaMa. LLaMa stands for Large Language Model Meta AI. We're going to use a Raku package called www.llama, right? You can install this package from the Zeph ecosystem or from GitHub. I'm going to be using a particular packaging of the LLaMa models. It's called llamaFile. This is a project by Mozilla. It is pretty straightforward to use those files, llamaFile models. You download the file, you change the permission, you run it. And so here are the available models. I have downloaded around 6 of them. We're going to use one of those models, Mistral 7B Instruct. And so when you run these files, llama files, you automatically get this interaction dashboard. So I'm going to talk to it, dictate. How many people live in Brazil? And so you can see, basically there's some interaction. And so when the request finished, some statistics about the evaluation time, etc. We're not using this. We're going to use the LLaMa models programmatically. And so the LLaMa models at this point, this LLaMa package in Raku has been integrated with some of the other functionalities in Raku for accessing large language models. So large language model functions, they can use this LLaMa package. They're also integrated in the Raku chatbook. So I'm going to show this here. So it's like say this is a magic cell, and I'm saying llama, and I'm saying give a short description of the animal raccoon. So this is specifically for the target audience of this presentation. And so more or less we are kind of going through the elements of this flowchart, although this flowchart represents a more generic chat cell to be used. From now on, for the rest of the presentation, we are going to directly interact with the LLaMa model through the this www.llama package. All right, so there's some setup to be done. By default, this is the base URL which is being used, and you can also see it here when you run the model, the LLaMa file. Somewhere here it says to which URL it's the LLaMa server is listening. Also, actually, since I'm here, I'd like to point out something I should have mentioned initially. I did run this model with a certain context size, 4096. This is the number of tokens which are allowed to the input. I want to be also to be able to use embeddings. 3 people at the same time, 3 users can access this service, and the number of threads is 40. All right, so here it's how we can change the URL. We can also change it to the original one. The LLaMa file executable can take a file with authorization keys, and you don't need them. We don't need them to run the models themselves, but if you want to have authorization keys, you can do that, and then you can use LLaMa file API key to access to have this key by default. So Raku chatbooks, we're using a Raku chatbook, already automatically loads this package LLaMa, but I mean, if you're using a script, you have to use this use statement here. So you can see, so this is one of the functions of the LLaMa package. It's an umbrella function, LLaMa playground. So I'm asking here what is the speed of a rocket leaving Earth, and you can see we're getting the result together with some other elements here. If we say that we want the format to be values, then we will get the result just as text. So here this is in Bulgarian. It says in Bulgarian, asks how many groups of points can be found in this cloud of points, and we more or less getting the results in English. And so this seed here means that every time we execute this command, we are going to get the same result, and presumably because of the seed, right? So with this function llama model, we can see what is the model which is actually being run. So this extension is being used for GGUF. It's being used for models trained with basically means GPT generated, and you can use other GGUF files to run with the llama file servers. So there are two generations, types of generations, text generations. One is like text, the other is chat, right? So they're kind of similar, kind of not. They're actually different. The web API for them, the endpoints are described in a different manner. And let me actually show this. So somewhere here, and I don't need to show this terminal anymore. So somewhere here, we do have the description of the endpoints. And so the simple completion, which is the text completion, is it has a different signature than the chat completion. Chat completion, on the other hand, is fully compatible with OpenAI's chat completion, which is very convenient. And this is one of the ways for me to implement access to llama files, llama models in the chat book, right? This is to use OpenAI with a certain URL. I'm not doing it in that way at this point. The Raku chat books, they're completely aware of the llama models, llama package. All right, so back to where I was here with the code generation. Let's do the chat generation. So llama chat completion is it has a synonym, just llama completion. Most of the models, large language models, they go away from simple text completion, and they orient themselves, focus themselves on chat. And so you can see this here. So what is the difference? So you can see that in a sense, this here, generate Raku code for making a loop of a list, because I didn't use any punctuation. This punctuation mark, right, the comma was put, and then it was completed. This sentence was completed in this way. Now here, this is taken as a message in a chat, so basically some interaction. And so this answer here is a chat answer. It's not a completion answer. All right, so embeddings, they're pretty straightforward. So I have this 3 or 4 statements. The first 3 statements, they belong to the machine learning subculture of classification. They're kind of related, not explicitly so. The last one is obviously quite different. It's about asking for a cooking recipe. So here I get the embeddings. So let me actually show some summary of this, and let me do the dot product between the embeddings. These are vectors, right? And so we can see that these vectors, they have 4096 elements. And so when I do a dot product between them, you can see that the last sentence, the 4th one, is an outlier, right? It has the smallest score if you compare it to the other 3, to the matrix of the other 3 with the dot product. One convenient feature is being able to tokenize the result. And so you can see here, I've tokenized the first sentence of this queries here, right? So this is the make a classifier with the method random forest over the data df Titanic, right? So we see the list of tokens, and then I'm detokenizing this list of tokens. We got something very similar, right? This actually, let's actually see this. So this is downloading a certain large body of text. It's HTML to a certain article by Stephen Wolfram, Can AI Solve Science? So you can see we have quite a lot of characters, 20,000 words, and so forth, right? I can tokenize this, right, with this service. So although the limit is 4096, I can tokenize the whole thing. And so llama file and llama models, they do have some additional features about caching prompts and caching tokenization and so forth. I haven't went through that yet to be implemented in this package, but just the fact that we can do the tokens and count tokens in this way, it's very helpful. All right, so here I'm going to demonstrate how we can integrate with the prompts. So there's a package called LLM prompts, and it has this some predefined prompts like say emojify, and I can run this LLM llama chat completion, and I'm saying that my prompt is this body of text here. This is what the system is, and the user says that Python sucks, Raku rocks, and Perl is annoying. And here we get the emojified version. So let's actually do something else here. So this here does translation, right? So this is like a round trip translation, so to speak. We're starting with the sentence, what is this about? Then we're asking this to be, I have defined this LLM function, right? Which uses the llama configuration. And so you can see this function f2 is being invoked over this text, and I want the translation to be into German. Then we got the German translation, and then we got from the German translation we go to English, and you know, almost kind of the same as the original text, right? All right, so one of the most interesting projects for me is using large language models to streamline machine learning workflows. And for that reason, I mean, one of the chosen strategies is to use this question answering systems. And implementing question answering systems can be done in several ways, but one way is to use large language models. And here is a demonstration how this text colors in preference order: blue, red, green, white, pink, cherry, light brown. How over this text we are asking these three questions: how many colors are listed, what is the favorite color, which is the third color, and we kind of get more or less results which make sense. Unfortunately, you can see the third color is not red, it's actually green. And maybe if we run this multiple times, we might get somewhat different results. I mean, actually, I'm not sure how did I specify the temperature, but anyway, yeah, these questions could have been all answered depending on the model you use, and so this is one of the ways I'm kind of testing these models. So llama files like lava, so-called lava incarnation of the llama files, and let me actually show here what I mean by this. So this is the Lava project because it has vision. So I have downloaded this, but I'm running this 7b instruct, which doesn't have vision. Anyway, I'm going to demonstrate how the vision is done. So here I loaded in the Raku session, and in this chat book I loaded this image, right? And now I'm going to ask for completion, right? And sorry, for a vision interpretation of this image. And in this particular case, the large language model, the llama model I'm running, it says that it doesn't know what to do with it, so being honest about it. So what I'm going to do here, it's I'm going to stop this this model, and I'm going to actually, let's see, I'm going to run this lava model, right? So, and I don't think I need to specify the context size, but let me do the context size too. And again, when it comes out, we're again seeing the dashboard. As I said, we don't need the dashboard, right? So here now I'm going to rerun this command. So the lava model requests asks, or it has this kind of pattern to make requests for vision. I'm specifying the image, but I need to specify also an ID, and then this img-77, which is here, right? It's basically the idea of this image. And if I have some text in which this image is used, I need to address it in this way with these square brackets. And so here, so let's see. So here actually, I'm going to zoom out. Ideally, you can see the text. The image features two cartoon-like raccoons sitting under a tree, each holding a basket. Well, just one of them is holding a basket, but you know, close enough. They're surrounded by multiple butterflies flying around them in the air, and so forth. All right, so well, pretty close. And in general, I would like to mention that with this llama models with vision I have experimented, so it's a little bit hit or miss, right? The explanations are pretty good, they're not that precise. Probably it's not even required. Some of the non-vision models, they tell you, they actually give you an image interpretation which has nothing to do with the image you give them, right? Some of these non-vision models, llama non-vision models, they do tell you, but they don't know how to deal with that. All right, so there's a command line interface if you want to use this from the command line, and this I think this mermaid diagram here just shows if you just use this package, not through a Raku chatbook, but if you use it, say, through the command line or in a script, what exactly is the sequence of operations that happen when you invoke these functions. All right, this was it. Thank you for your attention.